Hello and Assalamualaikum. My name is Iqmal Hakim bin Roslin. In this video, our group members from Group 10 of BMMD Section 1 Group 1 under the supervision of Dr. Sehazati Binti Rozali will be presenting our assignment report on application of second order system in refrigerator. So, the word refrigerator originates from the Latin verb refrigerare, which was derived from the Latin adjective frigus, meaning cool. A refrigerator is a home appliance that consists of a thermally insulated compartment and a heat pump that transports heat from the interior to the exterior environment, allowing the inside to be cooled to a degree lower than the room's temperature. Apart from that, a refrigerator features both a cooling mechanism and a freezer, and it is usually often referred to as a fridge to prevent confusion with a deep freezer that preserves temperatures below freezing point. Temperature control systems such as house thermostats and cruise control systems, which are typically found in vehicles, are two examples of closed-loop systems that people normally apply. Other than setting a set point, both rely on feedback and a closed-loop system to make automatic adjustments without user involvement. So, a refrigerator is a closed-loop system. Its temperature is monitored by a thermostat, which switches the motor on when the temperature rises above the set point, and the motor off when the temperature falls below the set point. Thermostats are most often found inside refrigerators, and they have a knob that allows users to adjust the temperature setting. The thermostat controls the cooling process by monitoring the temperature and then switching the compressor on and off. When the sensor detects that the refrigerator seems to be cool enough, the compressor is turned off by the thermostat. If it sends too much heat, it switches the compressor on and begins the cooling process again. So, a refrigerator thermostat, commonly known as a cold control, is the brains of the refrigeration system.
Assalamualaikum and selamat sejahtera. My name is Ibnur, and today I will explain about the block diagram for part C. As we can see, there are three important things in this block diagram, such as input, output and feedback. For input, we use preset reference temperature. For output, we use switch on and off the compressor. And for the feedback, we use temperature sensor or thermostat. Next, I will show the system modeling and transfer function for part D. This is our system modeling, and after we solve this equation, we got the G1 bracket S, G2 bracket S over 1 plus G1 bracket S, G2 bracket S, H over S. And final value, we assume the transfer function as 14 over S square plus 2S plus 4. Next, I will go through about the manual calculation that we get from this transfer function to find the peak time, settling time, percent overshoot and the rise time. To find this thing, we need to find two important things first: damping ratio and natural frequency. To find the natural frequency, we need to use this formula: negative Wn square equal to 4. After we solve this equation, we get 2 for our natural frequency for this transfer function. And next, for damping ratio, we need to use 2 damping ratio Wn equal to 2. After we solve this equation, we get damping ratio 0.5 for this transfer function. Next, to find peak time, we need to use this formula: pi over Wn square root 1 minus damping ratio square. After we substitute our value, we get the final answer is 1.813 second for our peak time. Next, for percentage overshoot calculation, we just use this formula: exponential negative bracket damping ratio pi over square root 1 minus damping ratio square times 100. Then for the final answer, we get 16.30. Next, for settling time, we need to use this formula: 4 over damping ratio Wn equal to final answer is 4 seconds. Lastly, for the rise time, we need to substitute our doubling ratio and natural frequency into this formula. Bracket 1.76 doubling ratio cube minus 0.417 doubling ratio square plus 1.039 doubling ratio plus 1 over Wn. After we calculate, we get the final answer 0.8178 seconds. Yeah, that's all from me. I will pass to Nabilah to explain about the MATLAB.
Hi, I'm Fatin Nabilah, and I will show how to get the system response of our refrigeration system by using MATLAB Online. We will begin to insert step input at the command window to get the system response by using the correct data and command. We use the data h equal to tf, which is transfer function, and we will insert our data 14, and then 1, 2, and 4. Then we will close the bracket, and then we use the command step load h, and we will wait for a while to get the graph of system response. Okay, here is our graph. And from this graph, we can get the value of peak response, which is the value for the peak time, which is 1.8, and we can get the overshoot percentage, which is 16.3. Also can get the settling time, which is 4.04, and we can get the rise time, (0.82), and from this graph we also can get the steady state, which is 3.5. We can also use command window to get the value from the graph by using command. Command is data equal to step info h. Okay, here is all the data that we got from the graph of our system response of refrigeration system. Next, I will pass to Haziq.
Hi, Assalamualaikum. My name is Muhammad Haziq, and I will explain to you how to convert the system transfer function into the state space representation. And let's begin. So, to begin this converting, we need to have a transfer function, and then our transfer function is 14 over s squared plus 2s plus 4. And then we're gonna put this transfer function into this equation, which is gs is equal to cs over rs, which is cs is the output and rs is the input, and it's equal to 14 over s squared plus 2s plus 4. And then from this equation, we're gonna cross multiply. It will be like s squared plus 2s plus 4 cs is equal to 14 rs, and then the s squared will be turned into c double dot, and 2s will be turned into 2c dot, and the 4 will be turned into 4c, and the 14 rs will be turned into 14r. So 2c dot will be changed into 2x2, and 4c will be changed into 4x1. Later I will explain it. And the 14r will be changed into 14u. And then we differentiate this equation, and it will be turned into d squared y over dx squared plus 2 dy over dx plus 4y equal to 14u. Basically, x1 is equal to c and x2 is equal to c dot.
and then we differentiate it, it will be turned into x1 dot is equal to c dot and x2 dot is equal to c double dot. So the equation of y is equal to c and is equal to x1. So the c double dot will represent as negative for x1 and negative minus 2x2 plus 14u, and then we put it into the table to get the matrices, and then the matrices will be as shown below. Okay, for the next question is about the stability system. Okay, to explain this stability system, we need to use the RH table, and then we put the value of our transfer function into this table based on the row and column. And then after we put the value of transfer function in this RH table, and then we do the calculation, and then we can conclude that the pole located at -1 plus minus squared 3i on the left plane of RHP. Therefore, the system is stable. Okay, for the last question is to calculate the steady state error for step input, ramp input, and the parabolic input. As you can see, we have the GS and the RS, where the GS is 14 over S squared plus 2S and 4 plus 4. For the RS, we have the 1 over S. And as you can see, we have the formula of E exponent infinity equal to limit S to 0 SRS over 1 plus GS. This equation comes from the GS, and from this equation we can take it and put into the exponent step, exponent ramp, and exponent parabolic equation, and then we put the value, and then we calculate and we get the answer. And then with the answer we can determine what is the type of our system, and from this answer we get, it determines that our system is a type 0 system. And that's all. Thank you.
Now for the discussion and analysis. In terms of enabling the temperature change, the control system utilizes a remote control, which is the thermostat, to send the signal to the compressor of the refrigerator. The thermostat will switch the compressor's motor on when the temperature rises above the set point, and off when the temperature falls below the set point. So the interior temperature of the refrigerator will be kept cool from time to time. When the temperature reaches desired output, the sensor will stop the process. When the temperature rises, the sensor will be able to detect and activate the flow process back. The sensor will also be able to maintain the desired output temperature. Next, for the transfer function, we assume that GS is 14 divided by S squared plus 2S plus 4 for the preferred input. From this transfer function, we have obtained the graph of the step response by operating a simulation using the MATLAB software feature. So we can conclude that from the calculation in RH table to determine the system stability, this control system is from type 0 because there is no pole located on the origin. The graph also proves that the system is underdamped and the system is in the second order system because the highest power of S is 2. From the graph, we were able to identify the peak time, the rise time, the settling time, and also the percentage overshoot. That's all for discussion and analysis.
In a conclusion, we have learned that combination of block diagram and transfer function is a powerful way to represent control system. In this assignment, we use refrigeration system as the refrigeration cycle allow us to move heat from one place to another against its natural flow of heat. As the system is a closed-loop system, a sensor is used to measure a process variable and provide feedback to the thermostat in the control system. Based on the system response that we obtain using MATLAB Online and manual calculation, this control system of refrigerator is considerably stable. That's all for us. Thank you.